afternoon, students. Welcome once again to our basic technology class for JSS 3. This afternoon, we are looking at the topic transmission of electricity at low and high frequency. We are looking at the topic transmission of electricity at high and low frequency. In the previous week, we have started this topic. We have been looking at this transmission of electricity at low and high frequency. Today, we are going to conclude the topic and explain more elaborately those parts that we didn't explain in the previous class. We start, first of all, by looking at electricity. The topic is electric transmission at low and high frequency. We are going to be looking at how electricity is generated, how it is transmitted, and how it is distributed. We are also going to look at the basic two types of electricity, which is electricity at high voltage and electricity at low voltage. It is electricity at low frequency that is called high voltage, and electricity at high frequency is also called electricity at low voltage transmission. So this afternoon, we are going to be looking at electric generation, transmission, and distribution. First, let's look at electricity generation. Electricity is generated from power sources and conveyed to the area where it is used, that is the load center, as an alternating current. That is an AC voltage, because it can easily be converted by transformers into higher or lower voltage as required. Now, electricity at high voltage is also referred to as high tension supply, while low voltage electricity is referred to as low tension supply. If you look at the slide here, you will see a pylon or towers, which are power lines holding onto electric cables as the electricity is being transmitted from the generating station. You also see in the adjacent picture here a substation, including all the transformers and other power lines that are used to convey the transmitted electricity and distribute it to our various homes. Now, let us first of all look at the ways of generating electricity and the sources. Now, electricity can be generated through the use of the following energy sources, that is, the solar energy. We can use what we call photovoltaic cells or solar cells, which trap sunlight energy, converting it to electricity to generate a quantifiable amount of electricity, at least enough electricity to power a whole building. Also, we have the mechanical energy, which is converted to electricity through a generating plant or a generator. This also produces enough electricity to power even a small city. Also, we have the hydromechanical energy, which is the hydroelectric power dams. This type of electric generation generates enough electricity to supply millions of people, and in Nigeria, the main source of electricity for most of the population is from the Kanji Dam, which is an hydroelectric power source generating enough electricity to supply almost the whole nation. Also, we have the wind energy, which uses the windmill to convert electricity through the use of wind turbines to convert wind energy to electricity. We also have the nuclear energy, which is generated at the nuclear power station, which generates enough energy also to power a whole nation or even adjacent nations as well. We also have some other electric generation sources like chemical energy, that is the use of battery. This would only generate enough electricity to supply maybe some few devices. We also have the heat energy generated electricity, which is through the device called the thermocouple. This type of electricity is usually very small in quantity and is not usable for even for any quantifiable purposes. Now, let's look at ways of generating electricity in large quantities. Now, whenever it is required to generate electricity in large quantities, we use what we call a power station. That is, the generating plant which generates this large quantity of electricity is called an electric power station. We have various types of electric power stations, and these are the following. We have what we call the gas turbine electric power station. The gas turbine station is powered by the generation of gas which is under very high pressure. This gas in turn turns an electric fan which is connected to a turbine and a generator. The generator here is embedded inside an electromagnetic field, and as it turns within this electromagnetic field, it generates electricity. Basically, this is the basic principle of electric generation. That is, whenever you have a coil of wire rotating in the midst of an electromagnetic field, electricity is generated in very large quantities. The same principle applies to the steam power station, where the turbine is turned by a steam that is under high intense pressure. The steam is usually generated by the use of coal or by the use of oil. That is, coal or oil is used as fuel to heat up water to the state of steam, and then it generates very high pressure which is used to drive a turbine, which in turn drives a generator which produces electricity. In the hydroelectric power station, a river source is dammed to raise the water level, so that this water, as it falls on the blades of the turbine, it turns this turbine, which in turn turns a generator which operates by the same principle of electromagnetic field to generate electricity. So in the hydroelectric power station, it is waterfall that is used to turn the turbine. Also in the windmill, and we use the energy of the wind, which is trapped by a wind vane, and which turns the turbine, which generates electricity. However, in the nuclear power station, we have what we call nuclear energy being transformed into electricity, also by producing a lot of heat to heat water into steam states. The nuclear power station here we use nuclear fusion, which generates a lot of heat to heat water into the state of steam, producing steam at high pressure, which drives the turbine, which in turn drives the generator, which generates electricity. So here we see the different types of power stations that we have, and as we have mentioned, in Nigeria we have the hydroelectric power station, which is the main source of electricity for the whole nation of Nigeria. Now let's move on and look at this inside a hydropower electric plant. Since hydroelectricity is the one that is used in Nigeria, we are concerned mainly about this source of electricity. Here you will see the dam that raises the water level into a reservoir. This water level, as it is raised by the dam, may now fall through a hole that has been drilled here to turn the turbine. The turbine in turn turns a generator which produces electricity. The electricity thus produced is transformed or stepped up by a step-up transformer into a high voltage. The high voltage electricity is then transmitted by power lines to the generating station or the power station. From the power station, the electricity is once again stepped down and then transmitted or distributed to our various homes and offices. We will see this in the next in the next slide. Now, in looking at transmission of electricity, as we have said, we have two types of electric transmission. One is called transmission of electricity at low frequency. This is electric transmission at high voltage. And the other one, that is the number 2, is electric transmission at high frequency. This is electric transmission at low voltage. First, let us examine electric transmission at low frequency. This electric transmission at low frequencies actually uses a transmission line, that is, cables and wires are used to transmit electricity at low frequency, which is at very high voltage. This is the transmission of electric power from the power station, which is conveyed or carried by underground cables or overhead lines, poles or tower over considerable distance. In this slide, you will see the generating station where the electricity is generated in red. You see the generating station is painted red, and then it generates the electricity, and the electricity is conveyed to the transformer, which steps up the voltage of the electricity generated and then transmitted through power lines or transmission lines and cables, which is colored in blue. That is, the transmission lines are colored in blue, transmitting the electricity to the substation. The substation here is painted in green. At the substation, the electricity generated is further stepped down into about 11 kilovolts or 33 kilovolts, and then distributed to your various homes, factories, and offices as required by using poles and pylons. So this is how electricity is generated, transmitted, and distributed to our various homes and offices. You can see that in this diagram as illustrated. Now, let us also look at it once again, step-by-step power transmission and distribution. Now, the power from the generating station, as we said, is stepped up to 132 kilovolts or 330 kilovolts and transmitted to the power station. That is the one that you will see very high and tall pylons or electric poles, which are made of very solid steel that are standing on what we call the power lines. These particular cable carrying pylons do not supply electricity directly to our homes, but are carrying the electricity from the generating station to the substation. And then at the substation, the electricity generated and transmitted is stepped down by a transformer to 33 kilovolts or 11 kilovolts. And then the high voltage is then transmitted through the transmission line to the distribution substation. It is then distributed to the various factories, homes, and offices where it is used. Now, as we said, electric transmission at high voltage is actual electric transmission at low frequency. The frequency of this power is 50 Hz in Europe and Africa and 60 Hz in North America. You can see a diagram here of a typical supply system, generation, transmission, and distribution of electricity of the alternating current. You will see the generating power station here. The generating power station could be a windmill, it could be a nuclear power station, it could be a solar cell station, it could also be an hydroelectric power station. After it has been generated, it is then transmitted to the transformer, which steps up the voltage to a very high amount, and then it is transmitted by high pylons or what we call transmission line to the substation. At the substation, it is further stepped down to about 33 or 11 kilovolts, and then it is now distributed by electric poles to our various homes, offices, and factories. Okay, so now here in this picture we see an example of a picture of an electric substation, how it appears. Now let's look at some of the components which transmit this electricity at low frequency. Number one is the generator control panel. The generator control panel is located at the substation. It is where electricity is now conveyed or distributed to our various homes and offices. It is here that electric power on or electric power off is actually done. Then of course we have number two is the circuit breaker. The circuit breaker ensures that the current is broken whenever there is an overflow of current, or if the current exceeds the amount that is supposed to be carrying. The circuit breaker breaks the circuit of the current. Then of course we have the substation. The substation is where the power that is being transmitted from the generating station is now stepped down and then transmitted onward to our homes and offices. Then of course we have these transformers which step up or step down voltage. Then we have the line support, which are high towers and poles which hold the electric cables and lines. Then we have insulators and lightning arrestors which ensure that the electric does not overflow to where it is not required, so that people do not experience any electric shock. Insulators are installed at the top of the poles to insulate the electric wire from the poles which are holding the wires themselves. Then of course we have the transmission lines, which are cables and wires which actually carry the electricity itself. Then of course we have a pole that is called the feeder pillar. It's a pole that carries the cable that connects your home with electricity. You will see that pole outside your house. Your electric cable is connected to electricity through that feeder pillar. Then we have the ring main unit, which is where the electricity that comes into your house is first of all, where the electric wire first of all enters into your building. Then of course we have the bus bar chambers and the fuse board, which are also embedded on a fuse board in the front of your house, where electricity is connected to the feeder pillar, that is the pole standing right in front of your house, where electric cable connects electricity to your house. So with this, we will stop. We come to the end of electric transmission at low frequency. Now let's move on to electric transmission at high frequency. But before we do that, let us quickly look at factors affecting the resistance of a conductor. A conductor, of course, is a metal or any substance that can conduct electricity. Now, in this particular instance, we are looking at electric cables and wires and the factors that affect the resistance of these conductors. Number one is the material of which the wire is made. Now, most electric cable or wires are made of copper. Why? Is because copper has a very high conductivity. That is, copper is one of the most conductive metals that we have. The most conductive metal in existence is silver. After that is copper. But you see, it will be an enormous expense if you have to make our cables and wires with silver, because silver is a very, very precious metal. So we make wires of copper, which has a conductivity which is close to that of silver. So the material of which the wire is made from determines the resistance of the conductor. Also, the length and the thickness of the wire will determine whether the resistance of the wire is high or whether it's low. Another factor contributing to the resistance of a conductor is the temperature of the wire. Now, let us quickly also look at power in electric lines as electricity flows through the line. The power lost in the line is given by power equal to I squared R, or P equal to IV, or P is equal to V squared R. In this particular equation, the V is referring to the voltage in volts, I is the current in amperes, and R is the resistance in ohm, values of the circuits and lines. That is, the values of the current, the voltage, and the resistance of the wire that is under consideration. And the power will be given by any one of these three equations. Now let's move on to looking at electric transmission at high frequency. Now, electric transmission at high frequency is actually transmission of electricity, which is a broadcasting medium, that is radio transmission or television transmission. This electric transmission is not usually done by cables and lines, but is by an electrical and magnetic field. That is, the transmission of power is by a combination of electric and magnetic field, and is defined as the transmission of power from the power station, which is conveyed by electromagnetic wave or radio wave through vacuum or without the use of cables. That is, the transmitting station, which may be the television station or the radio station, where the broadcast is generated, is then transmitted through vacuum to our various homes and offices. So if you have a television or a radio, which is the device which receives the transmitted electromagnetic wave, you can thereby decode and watch whatever is being broadcasted from the television station or the radio station. So the electric transmission in this particular case is the transmission of information or data, as you may want to put it. That is, this is electric transmission that transmits data and information through radio or television, as the medium of reception. Now, let us look at the source of electric power for electric transmission at high frequency. The source of power of electric transmission at high frequency is the transmitter. The transmitter is a piece of equipment which transmits electromagnetic waves or radio waves. This transmitter is enabled to transmit it by generating the required wave and then coding it and then transmitting it through the use of an area. And then we have the receiver, which may be a radio or a television set, which receives the transmitted electromagnetic wave or radio wave. And then we also have devices that can perform both function of transmitter and receiver, And this type of device is called a transceiver. That is, any device that could perform the function of transmitter and receiver is called a transceiver. An example is your mobile phone. Your mobile phone it can transmit information and as well receive it. Alright, let's look at the basic elements of radio communication or broadcast. Number one is the microphone, which is used to control the radio wave accordance with the information to be transmitted. Number two is the radio transmitter that will generate the radio frequency waves. Number three is a transmitting area to send out the wave into space. Number four is a receiving area. The receiving area is now in your home to come across a portion of the radiated radio waves, that is your radio or your television area, now come across a portion of the radio waves or the television waves and then transmit it into the receiver, which is a device inside your television or radio. So number five is a radio receiver to select and amplify the desired transmitter signal and extract the information out of the radio waves. After this has been done, number six is the loudspeaker to convert the information signals, which are in form of electric current, back into sound, which will be a close replica of the original information sent out. Now let's look at these basic elements of radio communication in a diagram. You will see the microphone here, which is used to generate the particular data or information. The transmitter here codes the information and then codes it and converts the sound information or the visual information into electrical signals and then transmits it through the transmitting area. And then when this transmitting area transmits the signal, the receiving area receives it and then conveys it to the receiver. The receiver here then converts the received electronic signals, converting it back into human voice type of information. This information is then heard through the loudspeaker, which echoes or brings out the sound of the information that was at first spoken through the microphone. So these are the basic elements of radio communication or broadcast. Now let us look at what we call wavelength, frequency, and speed of wave. That is in relation to the transmission of electricity at high frequency. Now the wavelength, frequency, and speed of waves are related by the equation below. The speed of the wave is equal to the wavelength multiplied by the frequency of the wave. Now the speed is in meters per second. Frequency, the SI unit of frequency, is the hertz, and the wavelength is in meters. Now if we have a wavelength of a radio wave, for example, if the frequency of the transmission is 20 hertz, while the radio wave travels at the speed of 3 multiplied by 10 raised to the power 8 meters per second, then the wavelength will be equal to the speed divided by the frequency, which is 3 multiplied by 10 raised to the power 8 divided by 20, and giving us a wavelength of 1.5 times 10 raised to the power 7 meters. This is an example of how the speed of an idea of the speed of the frequency of electricity at high of electric transmission at high frequency. You will see that the speed is quite high indeed, and the wavelength also is also very enormous. Now finally, we have our assignment. In this assignment, you have been asked to answer just 4 questions. The first one is that you should differentiate between electric transmission at high and low frequency. Number 2, list and explain the function of 5 components of electric transmission at high frequency. Number 3, list the 6 basic components of electric transmission at low frequency and explain the function of each. And finally, number 4, list 5 methods of generating electricity. With this, we come to the end of the topic for today. Please, you are to type your assignment and submit it on the WhatsApp forum. Do not write your assignment on paper and then snap it. Please type your assignment on your WhatsApp forum and then send it to my number. Also, please include your name. With this, we come to the end of today's topic on the electric transmission at high and low frequency. Thank you and have a good day.